A helicopter can lift thousands of pounds into the air, but if the engine stops, it doesn't just fall straight down. How is that even possible? In this video, you'll see how raw metal turns into one of the most complex flying machines ever built. Watch till the end, because what you're about to learn might completely change how you see helicopters. So friends, before watching the full video, subscribe to our Mandarin Tube channel and stay with us. The helicopter industry produces only a few thousand units each year, yet it generates between $30 and $50 billion annually. Each helicopter takes 6 to 12 months to build and contains over 20,000 individual parts. What makes this industry unique is that most of its value doesn't come from selling helicopters, but from operating them in rescue missions, medical transport, and offshore operations. This combination of low production, high complexity, and massive value makes helicopters one of the most advanced machines ever created. Once the design is finalized, material preparation begins. Large aluminum sheets are inspected using ultrasonic testing to detect hidden defects. Meanwhile, carbon fiber composites are built by layering fibers at different angles, like 0 degrees, 45 degrees, and 90 degrees. These layers are then compressed in an autoclave under high heat and pressure to form strong, lightweight structures. By the end of this stage, all materials are carefully prepared for the next steps. In this stage, metal parts are precisely cut and shaped. Aluminum panels are cleaned and prepared for bonding with composite materials. Carbon fiber layers are applied in specific orientations to improve strength in multiple directions. Special adhesives are used to bond everything together without trapping air bubbles. Under controlled heat and pressure, these layers form a reinforced structure that becomes the backbone of the helicopter. Now the airframe starts taking shape. Large panels are positioned on precision jigs and assembled piece by piece. Robots and workers install thousands of rivets, securing each component with exact force. Inside, the main structural frame is installed to handle heavy loads and constant vibration. Finally, a 3D laser system scans the entire structure to ensure perfect alignment before moving forward. In this stage, all major systems come together. The engine, gearbox, and drive shafts are installed and aligned with extreme precision. Laser tools ensure everything is perfectly positioned, as even small errors can cause serious issues. Then the rotor system is mounted on top, completing the helicopter's lift mechanism. At this point, the aircraft is nearly ready for operation. Now the helicopter is prepared for real-world use. Multiple layers of protective paint are applied to prevent corrosion and damage. The cockpit glass is installed, designed to withstand high pressure and impacts. Inside, seats, belts, and interior components are added. By the end of this stage, the helicopter looks complete and ready for testing. Before flight, the helicopter undergoes strict testing. The engine is started, and the rotor spins gradually to high speeds. Sensors monitor vibration, temperature, and pressure in real time. Even the smallest irregularities are detected and corrected. Fuel systems in sealed areas are also tested for leaks. This step ensures the helicopter is safe and reliable. Now comes the most critical phase, flight testing. The helicopter lifts off at low altitude and performs basic maneuvers. Pilots test hovering, climbing, descending, and directional control. Sensors collect hundreds of data points every second to analyze performance. Later, the helicopter is tested under more challenging conditions, like strong winds and heavy loads. A helicopter is not just a flying machine. It's the result of extreme precision, advanced engineering, and decades of innovation. From design to flight testing, every step must be perfect, because even the smallest mistake can impact safety. That's what makes helicopters one of the most complex machines ever built. So here's a question for you. Which part do you think is the most challenging? The design, the rotor system, or the flight testing? Let me know in the comments.